Okay, section 1.3 is called using reasoning to find a counterexample to a conjecture. Remember that a conjecture is just an assumption, a conclusion, a statement based on the evidence that you see, okay? So it says in the keep in mind section here that gathering additional evidence can support your conjecture, but the evidence cannot prove that your conjecture is true. But a counterexample, and this is an important word, okay? A counterexample is an example or evidence that does not support your conjecture. And if you can find one single counterexample, you've disproved your conjecture, okay? So because you keep finding things that can support it doesn't necessarily make it true, but the second you find something that disproves it, you know for sure it's not true, okay? And if you find a counterexample, you will have to revise your conjecture because now you know that it's not true. So there's just one example in your book here. And it says, examine this pattern in the product of 11 and another two-digit number. It says, what conjecture can you make about the pattern? And how can you check whether your conjecture is true? Okay, so let's look at what happens. We have everything's being multiplied by 11. Okay, so this stays consistent, all right? And then what happens is we are multiplying 11 by another two-digit number. So started with 11 times 11. 12 times 11, jump to 26, and up to 43. So let's look at the pattern that we can see. You can see here that when we multiplied 11 by 11, okay, the 11s in the two-digit number ended up being the first and the last number here, okay? So let me show you. This 11 ended up here. Use a skinnier pen. This 1 ended up here. Okay, look at how this 2 ended up here. This 6 ended up here. This 3 ended up here. And then the same. This 1 got here. This 2, first digit here. There. Okay, making a mess, but this 4 ended up there. All right. Now what about this middle term? Okay, what can you say about this middle term compared to these two numbers? What can you say about this middle 3 compared to these two numbers? This 8 compared to the 2 and the 6, and this 7 compared to the 4 and 3. Okay, so hopefully you can see that that middle term is actually the sum of the digits in that two-digit number. So my conjecture can be that my pattern is any two-digit number. So I'm going to call the first digit A and the second digit B. Okay, so times 11. So any two-digit number times 11, and A will be the first digit, B will be the second digit. Okay, so that would be A, that would be B, that would be A, that would be B. I end up with A being at the front, B being at the back, and what was that middle term again? It was A plus B. Okay, so that's what I noticed happening. That was my pattern. So that's my conjecture. That's what I think is going to happen. Okay, so anytime I multiply a two-digit number by 11, I'm going to get this pattern. Okay, how can you check whether your conjecture is true? Well, try some other examples. So what if I go 10 times 11? Okay, based on my pattern, I should get a 1 at the front, because that's A. I should get a 0 at the back, because that's B. And then when I add them together, that's my middle term. Does that hold? Is 10 times 11 110? Sure is. Let's try it again with something else. Let's go 13. 13 times 11. Okay, based on my pattern, I'll get a 1 at the front, a 3 at the back, and the sum 4 in the middle. Okay, if I check my calculator and multiply 13 by 11, I do indeed get 143. Okay, so far what's happening is these are supporting my conjecture. I haven't found a counterexample yet, okay? Because so far I'm supporting. All right, let's try something like 19. Okay, so based on my pattern, 1 in the front, 9 in the back, and then the sum, I have to get a 10 in the middle. Well, I know for sure that 19 times 10 isn't 1109. Okay, so there's a counterexample that does not support it. So I can say that as soon as I got over 10, well, 11 worked, 12 worked, 13 worked. Ooh, let's try 14. Let's try 14. 14 times 11 should be a 1, a 4, and a 5 in the middle. Get out my calculator. 14 times 11 is 154. Huh. Okay. 15. 15 times 11. 156. Well, that works. Because if I take 154 and I add 11. Okay. So I wonder where it changes. 19 didn't work. What about 18? Did 18 work? You know what the problem with 19 was? When I added 1 plus 9, I got 10. And that's why I put that 10 in there. What if I added the 1 plus 0? Or what if I put just the 0? That was sort of confusing. I wasn't really sure what to do. What about 18 though? 18 times 11 should be a 1 and 8 and a 9 in the middle. 18 times 11 is 198. But as soon as I got to 19, that's when the difficulty started because I wasn't really sure what to put in the middle. 19 times 11 should be 1 and a 9, and then what goes in the middle? Well, the sum. Do I put 10? Do I put 0? Do I put the 1 from the 10? And none of those work. So the second that my 2-digit number added to a 2-digit number, it didn't work anymore. Okay, so 19 is where my conjecture fell apart. So that's where I'm going to have to revise it. So I can type easier than I can write, so I'm going to go ahead and type. I'm going to revise my conjecture. Okay, it's got to do with when I add those two. So I'm going to revise it to given a factor AB, so that was the 2-digit number, where A plus B is less than 10, the product of 11 and AB will equal A plus B. That's going to be my new conjecture. I'll make it blue. There we go. Okay, so remember that right here, as soon as we ended up with this 2-digit number, adding to something that's bigger than 10, it didn't work anymore. Okay, so let's try one more time where we pick a bigger number, but it doesn't add. Like, let's go 81 times 11, okay, because 8 plus 1 adds to 9. So I'll have the 8 and the 1 there. And if I check on my calculator, 81 times 11 is 891. Okay, so I revised my conjecture to be as long as A plus B is less than 10. All right, that's section 1.3.